Hello everybody. Today on Leetcode, we'll be solving Leetcode medium difficulty question number 3. Longest substring without repeating characters. In this video, I'll go through the steps that I took to get to an acceptable solution. I'll first present to you guys the slowest solution, followed by a slightly faster but not quite optimal solution. And finally, I'll present to you the fastest and accepted solution. Throughout the video, if you feel like my pace might be a little bit too slow or too quick, feel free to skip or pause at any of the sections that you need. The reason why I wanted to explain the two slower solutions is that I find, at least for me, when I get to the point where I have a working solution, it's correct, but it's not fast enough to pass the problem. I find it helpful when I try to see what parts of my algorithm that I have is slowing things down. I try to see if there's any components that I can tweak to speed things up. And a lot of times to do this, I have to try to find if there's some pattern and some trick that I'm not utilizing yet. This will all make sense in a bit once I explain the two slower solutions and transition from those two slower solutions to the final accepted solution. Okay, without further ado, let's get right into it then. Given a string S, find the length of the longest substring without repeating characters. Okay, so let's just say this is my string. The circles are the characters. And let's say that we're given string of length n. So in the slowest solution, what we're going to do is we're going to just look at all the possible substrings that we can construct from this string. Check if those substrings, each of those substrings, have repeated characters. And then after we go through all of them, return whatever, substring without repeated characters is the longest, right? How long would this take? Well, first of all, how many different substrings can I construct from a string of length n? Well, each substring has to have a start point and an end point, right? How many start points are there? There's n starts and there's n end points. So in total, I get n square substrings. How long does it take for me to check if a substring has any repeated characters? Well, that will take O of n time, right? We just go through the substring and just keep track of all the characters we've seen so far. So the runtime of this algorithm will be equal to the time I take to go through all these n squared substrings. And how long would that be? Well, since I already said it takes O of n time to go through an individual substring, then it'll take O of n cubed to go through all the n squared substrings, right? O of n squared times O of n. Okay, this is definitely not the fastest solution, obviously, right? We're not really taking advantage of anything, really. We're not really factoring in anything about what it means to be the longest substring, right? Okay, so now let's move on to the slightly faster solution. So we know that there's n squared substrings total, right? And in the slower solution, we're searching through all these n squared substrings one at a time. Can we somehow shrink the number of substrings that we look at? We shrink the search space of the substrings that we end up looking at. Let's just look at the longest substring, starting at some index I, right? How many possible ways can we start a string at? There's, like I said earlier, there's n starts, right? So there's n longest substrings at some index I for all possible i's. So if I can find these n longest substrings at some index I, what I can do is I just compare these n substrings, see which one is the longest, and that'll be my final answer, right? And my runtime for this algorithm now will just be the time it takes for me to find the longest substring at some index I times n. So how long does it take for us to find the longest substring at some index I? Well, the way we can do this is rather simple. Let's say we start here. This is my starting index for whatever substring that starts at this index. We want to find the longest substring without repeating characters. What we do is we keep track of the characters that we've seen so far. We look to the right. see if this character is here. If it's not, we add into our substring. Now we have a substring of size 2. We do this again to the right. If this character is not in it, we add to it. We keep doing this until we find a character that's already present in our current substring. So how long does this take? Well, that takes O of n time. So O of n for each O of n time it takes to find each of the longest substrings at each index I. There's n total possible starting indices. So n times n, we get O of n squared. Okay, so now we sped up our algorithm by a factor of n. Can we speed things up even more? Let's see if there's some underlying, pattern that we're not utilizing. This will all make sense in a bit. Okay, so let me erase this for now. And let's erase this. Okay, so back to our example here. Say we have our longest substring starting at this index. It starts here and it ends here. And, whatever repeated character that shows up here, let's say that repeated character shows up here. Can we say anything about the longest substring starting at this index? With no repeating characters, of course. Yes, well, wouldn't the longest substring starting at this index with no repeating characters also end here? What about the longest substring with no repeating characters starting at this index? It should also end here, right? You see the pattern now? Well, this doesn't go on forever, obviously, because if you look at this, index, what's the longest substring starting at this index? Well, you don't know, because all you know is that this character that repeats here is repeated here. We don't know if the longest substring starting at this index, it could go on forever, basically, is what I'm trying to say. Okay, so knowing this fact, how can we shrink the number of substrings that we're examining? Well, since we know that the substrings starting at this index and this index all end at the same spot as the longest substring that starts at this index, then we know that the length of the longest substring starting at these indices are all upper bounded by the length of the longest substring starting at this index. And we're trying to find the longest substring in the total string, right? So we can essentially ignore these two indices and their associated substring that starts at this indices. So here's where the term sliding window comes in. For those of you who haven't heard of this term before, this question, longest substring without repeating characters, is a question like this it's a very typical problem to showcase this concept of a sliding window. I'll explain that in a bit. So the sliding window, what it is that it'll have two sides, like a window, right? A window has two sides. There's a side here and there's a side here. So what are the two sides to my window? Well, the way my algorithm is going to work is I'm going to have a window and I'm going to be shifting the left and the right sides of the window until the right side of the window hits the end of the string. What my solution would be the maximum length that this window will ever be. How does this translate to our problem? Well, let me explain to you how I get the left and the right sides of my window. Okay, so let's say this is the start of the string, right? I'm going to set the left side of my window to be where the start of the string is. So the starting index, that is also. So the right side of the window, where is it going to go? It's going to go one index before the first repeated character shows up in the longest substring starting at this index. So that will be right here. This is going to be my window. And notice how the length of the window is equivalent to the length of the longest substring starting at the index where the left side of the window is located, right? Okay, so how do I, move my windows, the sides of my windows? Well, like I said before, we don't have to look at these indices anymore. So what we do, these indices, meaning these indices between whatever I'm at and the first, where the repeated character shows up. Okay. So what I'm gonna do is my algorithm will find this repeated characters index, and I'll simply move my the left side of my window to this location. I'll move it one to the right of this location to mark my next new left side of my window. Why am I doing this? Well, like I said before earlier, we don't know any information about the longest substring with no repeating characters starting at this index, right? So we have to find out what the longest substring starting at this index is. And like I said earlier, the left side of the window corresponds to the start of the substring, starting at whatever index the left side of the window is, right? So now I need to find the right side window. Again, this corresponds to where the longest substring starting at this index with no repeating characters will end. And let's just say it's somewhere here. So we keep doing this until we get to until the right side of the window gets to the end. And that's where our algorithm will terminate. Very neat, right? So let's try to code these up now. Okay, so forgot to remove my previous failures, but anyways, let's start off with a blank slate. Okay, let's remove this. Okay, so we want to keep track of the length of the window is ever, right? So let's have a variable called longest. Let's just keep track of that. We start out having, we're shifting our left to right sides of a window. So let's have our left window be called left. And remember, it starts at the first index, right? So left equals 0. And then we're going to be shifting our right side of the window. So for right in range like best. This is the process of me shifting the right and left windows. So, at the start, in the beginning, right, I establish my left side of the window to be in the first index. I have to find where the right window is, and that corresponds to finding where the index right before I see my first repeat character, right? So how do I do this? Well, I need to make sure I keep track of all the characters I've seen so far. So let's use a data structure, a set. And we know that if we see a character that we've already seen before, which corresponds to this. If it's already seen before, then this is the case where we have to establish a new left, right? We have to move the left side of our window. So let's have a variable called new left, and that would always, new left is always going to be to the right of whatever index the old left window used to be at. Okay, so new left equals left. To find the new left, what we have to do is we have to find this index, right? So how do we do that? Well, we loop through the left side and the right side. Check to see if it's equal to s of right. What is s of right? That's the repeated character that we came across. So if it's equal to that, then I know I have to stop this for loop. I have to change what my left is. My new left should be updated. And I also need to, let's see, am I missing something? Yes. So the new left is one index to the right of the repeat, right? So it should be new left plus or equal 1. And then otherwise, this is the case where I haven't yet seen the repeated character. I just need to update my new left by 1. I also need to update my scene set, right? Since the characters that I'm keeping track of in the window, aka in the substring, they're not gonna be, I don't need to keep track of these characters, right? Once I move the left side of the window beyond where these characters lay. So I need to make sure that I remove whatever that I'm, move past on. So that would be equal to remove si. Yes, okay. The reason why I don't remove the repeated character is that, we're going to end up here again. So I'm not, if I remove the repeated character, I'm going to have to add it back before I start my next, iteration of the window sliding iteration. So I'm just not going to remove it. Okay, so now that I've done this and I updated my new left, okay, now we need to write the case where we simply have yet, found a repeat when computing the longest substring. Okay, so what do? Well, we have to update what it means. We have to update our longest variable, right? So that would be equal to whatever we currently have, and that would be equal to right minus left plus 1. And we also have to update what we've seen so far, right? We have to add in whatever that we just saw, okay? And then at the very end, is this lined up? Okay, now we return longest. Okay. Now we run the code. Okay, it works for this. Let's see if it works for the solution. And it should work. I tried this a couple times already. So, okay, so it does work. Yeah. So notice how we're able to transition from the original O of n cubed solution to the O of n squared solution and then to the O of n solution. When I first came across this problem, the biggest step was just realizing this pattern here, right? And this pattern stemmed from like the motivation to reduce the number of substrings I looked at, right? How do I prevent myself from looking at all the substrings? Because I can't look at all the substrings, right? If I do, then I'll end up with a solution, one of the slower solutions, right? The O of n squared or the O of n cubed solution. So I have to figure out how I can reduce the number of substrings that I look at. And to solve that question, we essentially exploited this, this pattern here in which that we don't have to look at these substrings starting at these indices anymore once we found what the longest substring at this index is, right? Okay, so that's it for today. And, if you have any suggestions for any questions that you want me to go over, feel free to leave a comment, leave a like and subscribe. This is my third episode in a series of Leetcode questions. And I don't know if this way of doing questions is what you guys want to see, especially if I feel like I might be rambling on a little bit too much, or I might be going into detail, things that are too simple. For example, what I mean by this is like I'm going into detail and things where it's very obvious what I'm talking about. So please, let me know if I'm doing something like that. And as a wise man once said, a Leetcode a day keeps unemployment at bay.